Hello friends, welcome to my YouTube channel Ik Onkar Coding. In today's session I will discuss bitwise operators. In the previous session I covered arithmetic operators and relational operators. Today we discuss bitwise operators. Now these operators are called bitwise because these work upon bit level. Here operand is treated as a sequence of bits. Basically we have 6 types of bitwise operators. First one is bitwise AND, second one is bitwise OR, then bitwise XOR, then we have left shift, then we have right shift, then we have bitwise NOT. Basically these operators are called bitwise because rather than operate on value, it will operate on bit, it will operate on bits. I explain you by example how these operators work upon bit level and how the output is produced and how these operations are performed in coding language. Okay, so the symbol of bitwise AND is single time AND. The bit symbol for bitwise OR is single time parallel line. Bitwise XOR symbol is cap. Left shift symbol is 2 less than symbol. Right shift symbol is 2 greater than symbol. Bitwise NOT is tilde sign. So these are the symbols that we use in coding language. So now we discuss one by one. So first we discuss bitwise AND operation. So I hope all of you know about the flowchart of bitwise AND. Suppose here we have X and Y and Z is the output. Okay, I hope all of you familiar with the AND truth table of the AND gate. Okay, if you have two inputs, how many combinations we have? We have 4 combinations: 0 0, 0 1, 1 0 1, 1 0, 1 1. So we have 4 combination. Now AND mean multiply. AND mean multiply. Okay, 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. Clear? So suppose we have two variables A and B. A has a value 25, B has a value 35. Now I hope all of you know how to convert a decimal number into a binary representation. So first I convert 25 into binary representation. So 0 1 1 0 0 1, this is a binary representation of 25. If you want to check this is a correct or not, you can make sequence 1 2 4 8 16 32. 16 plus 8 24, 24 plus 1 25. It means this one is correct. And in a similar way we convert 35 into binary representation. 32 plus 2 34, 34 plus 1 35. Okay, so we have to make the sum as 35, make rest of the bits as 0. So this is the correct representation of A is equal to 25 and B is equal to 35. Now I apply bitwise AND operation on both values A and B. So what I do is 1 and 1 become 1. 1 into 1 is 1 because using this truth table. 1 into 1 is 1. 0 into 1 is 0. 0 into 0 is 0. 1 into 0 is 0. 1 into 0 is 0. 0 into 1 is 0. So our output is 1. So if you apply AND operation, bitwise AND operation on A and B variable, this one is the output. So in this way we can display the output. In this way bitwise AND operation is performed on values A and B. I hope all of you clear. So now we move to the next operation. The next operation is bitwise OR. So now we discuss how to perform bitwise OR operation. Okay, so A is equal to 25. First I convert into binary representation 0111001. Second number is B is equal to 35. Again convert into binary representation. Now we apply here bitwise OR operation. So suppose X and Y is our input, Z is our output. How many combination? 4 combination. 0 0 0 1 1 0 1 1. Basically we have 4 combination. Now OR means addition. OR mean addition. Okay, now 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. So now we apply this bitwise OR operation on both variables A and B. This is a symbol, single parallel line used for bitwise OR operation. This symbol only used for bitwise OR. If in a coding language you encounter this symbol, you understand automatically that is user or programmer is performing bitwise OR operation. Okay, because this symbol is only used for bitwise OR. Okay, so you understand it you automatically. Okay, so 1 plus 1 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 0 is 1, 0 plus 1 is 1. So this is the output of the bitwise OR operation. Okay, I hope all of you clear about this. Okay, so now we discussed bitwise XOR. Now we discuss bitwise XOR operation again on both same values. Okay, so first we discuss what is the truth table of the bitwise XOR. Okay, if we have two inputs X and Y, how many combination? 4 combination. 0 0 0 1 1 0 1 1. Okay, now in case of XOR gate, now we are performing XOR operation. Now what we do in XOR? In XOR, if both inputs are same, output is 0. Both inputs are same, output is 0. Both inputs are different, output is 1. Both inputs are different, output is 1. So this is the truth table of the XOR gate. Now I apply this operation on both these values and this cap symbol used for bitwise XOR. Okay, I hope now you clear why why we call it as bitwise operator, because we apply these operations on bit level. That's why they are called bitwise operators. So 1 and 1, both inputs are same, output is 0. 0 and 1, both inputs are different, output is 1. 0 and 0, both inputs are same, output is 0. 1 0, both inputs are different, output is 1. 1 0, both inputs are different, output is 1. 0 1, both inputs are different, output is 1. So this is the correct output of the bitwise XOR. So now further we move to the left shift beta. This is the most important from the examination point of view, how to perform the left shift operation. Okay, so here we require only one variable or one value. So I initialize A with value 25. Okay, now after this, how this operation is performed? Basically left shift, the symbol for the left shift is 2 less than symbol. Okay, now 2 less than symbol have two sides, left hand side and right hand side. Okay, this is the symbol for the left shift. Okay, now on the left hand side, always use value. On the right hand side always use number of bits. Okay, so which type of operator it is? It is a binary operator, because we require two values. We also require this value on the left hand side, we also require number of bits on the right hand side. The thing is, by how many number of bits you want to shift the value of A? By how many number of bits you want to shift the value of A? And this symbol is decided that you want to perform left shift or right shift. Okay, this symbol used for the right shift and 2 greater than symbol used for the right shift operation. Okay, so here we are performing left shift. Now we discuss how to perform the left shift operation. So how we write how we perform this operation. So on the left hand side we use value, so I use here a, variable a, then symbol use here 2 less than symbol, then here by how many number of bits you want to shift, we are shifting by 3 number of bits, so I write here 3. Okay, now first a has a value 25, so I convert this 25 into binary representation. So 0 1 1 0 0 1, this is a binary representation of 25. Now this value have two sides, left hand side and right hand side. Now what we have to do, we have to perform the left shift operation. So it means this value is shifted on the left hand side. This values is shifted, this value bits are shifted on the left hand side because this one is the left shift. So in the left shift bits are shifted on the left hand side. Okay, so bits are shifted on the left hand side. How many bits shifted? 3 bits are shifted because here the value is 3. It means 3 bits are shifted. So these 0 1 1, these 0 1 1 are shifted to the left hand side. So it becomes 0 1 1, and 3 padding bits are added on the right hand side. 3 padding bits are added on the right hand side. Why 3 padding bits? Because you are shifted by 3 bits. So 0 1 1 as such, 0 0 1 as such, and 3 padding bits are added here. Okay, and after this if you convert into decimal representation, it become 200 because here we have the value 1, here we have 2, here we have 4, here we have 8, 16, 32, 64, 128. So perform the addition. 128 plus 64 plus 8, so it becomes 8 plus 8, 16, 16 plus 4, 20. So 0 here, 2 is the carry, 6 plus 2, 8, 8 plus 2, 10, 0 here, 1 is carry, so it becomes 200. So this is the correct answer. Okay, after left shift operation by 3 bits, this is the output. I hope all of you clear about this left shift. Another thing is, there is also one formula for calculating the output of the left shift operation. That formula is a multiplied by 2 raised to power number of bits. This is again one formula. What is the value of a? A has a value 25, multiply 2 raised to power. By how many number of bits you are shifting? 3. 2 raised to power 3 becomes 2 raised to power 3. Now we write 25 into 2 raised to power 3 becomes 8. So 8 5s are 40. 8 into 2 16. 16 plus 4 20. So this is again the correct output. Using this formula you can also calculate, and left shift operation is performed in this way. I hope all of you clear about the left shift operation. Okay, so now we move to the right shift. If anyone have any query, you can ask me in comment box. Okay, so now we perform right shift operation beta. Okay, now this is the symbol for the right shift. Again, this one is a binary operator. On the left hand side we always use value, on the right hand side we use number of bits. By how many number of bits you want to perform the right shift operation. Okay, so here I am shifting the value of a by how many bits? 3 bits. So here the thing is, first I convert this 25 into binary representation. 0 1 1 0 0 1, this is a binary representation of 25. Okay, now we are performing right shift operation. So bits are shifted on the right hand side. So this is the left hand side and right hand side of this value. So the bits are shifted on the right hand side because we are performing right shift. In the previous case bits are shifted on the left hand side because this one is a left shift operation. Okay, here bits are shifted on the right hand side, but this one is different from the left shift. Now what will happen here? So by how many bits you are shifting? We are shifting by 3 number of bits. So here last 3 bits, rightmost 3 bits are shifted on the right hand side, and 3 padding bits are added on the left hand side. Okay, 3 padding bits are added on the left hand side, and this 001 is losted. Whatever bits are shifted on the right hand side, they are losted beta. Okay, in this operation this 001 is losted. these 001 bits are shifted, these 3 bits are shifted and lost it. So after this, these bits are shifted here, 011, okay, and 3 padding bits are added here. If you convert into binary representation, the output is 3 because 1, 2, 4, 8, 16, 32, so output is 3. Or if you want to check by formula is, now if you want to check by formula, the formula, what is the formula? Formula is A divided by 2 raised to power number of bits, okay. In left shift, formula is A multiply 2 raised to power number of bits, and here formula is A divided by 2 raised to power number of bits. So what is the value of A? 25 divided by, what is the value of number of bits? Number of bits are 3. So 25 divided by 2 raised to power 3 is 8. Output is A3 the 24. Output is 3. And here also we have output is 3. I hope all of you clear about the right shift operation. Okay. So now we move to the last operator, that is bitwise NOT operation. Okay. Now in bitwise NOT, tilde is the symbol used for bitwise NOT. Okay, A has the value 25. Okay, so which type of operator is it? This one is a unary operator because only one operand is required. Okay, so first I convert 25 into binary representation, 011 001. This is the binary representation of 25. Now I use here tilde sign. Now how this sign will use, I hope all of you know about the NOT gate. If we have only one input, how many combination? Only 2 combination. For the NOT gate, 0 become 1, 1 become 0. So we apply this operation here. 1 converted to 0, 0 converted to 1, 0 converted to 1, 1 converted to 0, 1 converted to 0, 0 converted to 1. This is the output. I hope all of you clear about the bitwise NOT operation. Okay, so now we discuss by example. Okay, now we discuss by program. Okay, how we perform this operation in coding language. Okay, so first we include the standard header file, then main function, then I declare 2 variables A and B. A is initialized with value 25, B is initialized with value 35. Now I am performing bitwise AND operation. So I use here printf statement because we want to display the output of A and B. So I write printf, then round bracket, inside the round bracket include double quotes. Inside the double quotes I include a message. Bitwise and this is a message. A and B include in double quotes, so it means here this is also a message, is a message. So here percentage D is referring to A and B operation. Okay, so whatever value is produced by A and B, that is of int type. That's why I use here percentage D, and that value will display here in the output. In a similar way, I perform bitwise OR. This is a message, A parallel line B. This is the symbol for bitwise OR. This is also a message, is percentage D is referring to A bitwise OR B. So here whatever be the value, that value will display in the output. After performing the operation, the value will display in the output. In a similar way, we perform bitwise XOR. Bitwise XOR A cap B is, this is just a message, percentage D is referring to A cap B. So here whatever be the output, that will display. After performing the operation A XOR A bitwise XOR B, output will display in the output. Okay, value will display in the output. After this we are performing bitwise left shift. So here until here is, this is a message A, this is a symbol for left shift operation. Okay, so here this percentage is referring to A bitwise left shift 3. So we are shifting the value of A by how many bits? 3 bits. So that value will display. It means here 200 is the output, 200 will display. After this we are performing, because A has the value 25 na, that's why. So after this we are performing bitwise right shift. In a similar way, here what value will display? Here 3 will display for the bitwise right shift operation. After this bitwise NOT operation is performed. So here I use tilde A symbol. So here bitwise NOT operation is performed, then return 0 and program is ended. So in this way you can compile your code on the Quad Block or Wave C++ compiler. Okay, this is the correct code. I have verified this code and it will display the correct output. Okay, and if you have any query, you can ask me. Thank you all for watching my session. Kindly like and subscribe my channel. Thank you all.